Hello friends, now we discuss the second property of the Jacobian. If J1 be the Jacobian of if J1 be the Jacobian of UV with respect to x, y and J2 be the Jacobian of xy with respect to uv, then J1 product of J1 into J2, this is equal to 1. That is Jacobian of uv with respect to xy and Jacobian of xy with respect to uv, this is equal to 1. Here this is the second property of the Jacobian. If J1 is the Jacobian of uv function with respect to two independent variables x and y, and J2 be the Jacobian of xy function with respect to two independent variables u and v, then the product of J1 and J2 is equal to 1. That is, this is the Jacobian of uv with respect to xy and this is the Jacobian of xy with respect to uv. So this is the Jacobian of uv with respect to xy and this is the Jacobian of xy with respect to uv. So the product of Jacobian of uv function with respect to xy and Jacobian of xy function with respect to uv, this is equal to 1. So for proving this, first we suppose that let u is equal to uxy and v is equal to vxy be functions of x and y. Let us suppose that here two functions u and v. U is function of x and y, v is also function of x, y. Now we differentiate u is equal to uxy, v is equal to vxy with respect to u and v. Here it is given that there are two functions u and v. U is the function of x and y, v is also the function of xy. Now we differentiate this u is equal to uxy and v is equal to vxy with respect to u and v. So when we differentiate u is equal to uxy with respect to u, we get 1 is equal to, because differentiation of u with respect to u, this is equal to 1, and differentiation of uxy with respect to u, this can be written as del u upon del x multiplied by del x upon del u plus del u upon del y multiplied by del y upon del u. This is the differentiation of u is equal to uxy with respect to u. So differentiation of u in the left hand side with respect to u is 1 here, and differentiation of uxy with respect to u can be written as del u upon del x multiplied by del x by del u plus del u upon del y multiplied by del y by del u. This can be also written as del u upon del x, this can be written as ux, del x upon del u can be written as xu plus del u upon del y can be written as uy and del y upon del u can be written as yu. Now we differentiate u is equal to uxy partially with respect to v. U is equal to uxy, we differentiate this partially with respect to v, when we differentiate this u in the left hand side partially with respect to v, this is constant, so this becomes 0. And differentiation of uxy with respect to v, we get here del u upon del x multiplied by del x upon del v plus del u upon del y multiplied by del y upon del v. Here in the right hand side u is equal uxy, we differentiate this with respect to v. So this can be written as del u upon del x multiplied by del x by del v plus del u upon del y multiplied by del y by del v. Now this del u upon del x can be written as ux, del x by del v can be written as xv plus del u upon del y can be written as uy and del y upon del v can be written as yv. So this is the differentiation of u is equal to uxy with respect to u and v. Now we differentiate v is equal to xy with respect to u. Now we differentiate this v is equal to vxy with respect to u. So in the left hand side when we differentiate this v with respect to u, so v is constant here, so this differentiation is 0. Now in the right hand side when we differentiate this vxy with respect to u, this can be written as del v upon del x multiplied by del x upon del u plus del v upon del y multiplied by del y by del u. You can see here v is equal to vxy. We differentiate this partially with respect to u. When we differentiate in the left hand side partially with respect to u, so v is constant, so differentiation of v with respect to u is 0 here. And in the right hand side when we differentiate this vxy partially with respect to u, this can be written as del v upon del x multiplied by del x by del u plus del v upon del y multiplied by del y by del u. Now this del v by del x can be written as vx and del x by del u can be written as xu plus del v by del y can be written as vy and del y by del u can be written as yu. So this is the differentiation of v is equal to vxy with respect to u. Now we differentiate this v is equal to vxy partially with respect to v. So in the left hand side when we differentiate this v partially with respect to v, we get 1. And on the right hand side when we differentiate this vxy with respect to v, we get del v upon del x multiplied by del x upon del v plus del v upon del y multiplied by del y upon del v. You can see here v is equal to vxy. This is differentiate partially with respect to v. So in the left hand side when we differentiate this v partially with respect to v, we get 1 here. On the right hand side vxy when differentiate with respect to v, so this can be written as del v upon del x multiplied by del x upon del v plus del v upon del y multiplied by del y upon del v. This can be also written as, here del v by del x can be written as vx, del x upon del v can be written as xv, del v upon del y this can be written as vy and del y upon del v this can be written as yv. You can see that these are the differentiation of u is equal to uxy and v is equal to vxy with respect to u and v. Now you can see here we have to find the Jacobian of uv with respect to xy and Jacobian of xy with respect to uv. So we know that Jacobian of uv with respect to xy, this can be written as del u upon del x, del u upon del y, del v upon del x and del v upon del y. You can see here del uv upon del xy can be written as, by the definition of Jacobian, we can write this del u upon del s, del u upon del y, del v upon del s, del v upon del y. And this, by the definition, this can be also written as del x upon del u, del x upon del v, del y upon del u, and del y upon del. So, again this del u upon del x can be written as ux, uy, vx, vy. And in the second determinant, this can be written as xu, xv, yu, yv. Now we multiply these two determinants. So here we multiply first row by first column. So we get here ux, xu plus uy, yu. Similarly, we multiply first row by second column. So we get ux, xv plus uy, yv. Similarly, we multiply second row by first column. So we get vx, xu plus vy, yu. Similarly, we multiply second row by second column. So we get here vx, xv plus vy, yv. So here we multiply these two determinants. Now we put values here. So you know that ux, xu plus uy, yu, this is equal to 1 here, and ux, xv plus uy, yv, this is equal to 0 here, and vx, xu plus vy, yu, this is equal to 0. From the above discussion you can see, and vx, xv plus vy, yv, this is equal to 1. Now we solve the determinant, so we get 1 minus 0, that is 1. So this shows that del uv divided by del xy multiplied by del xy upon del uv, this is equal to 1, that is j1, j2, this is equal to 1. So if uv, if j1 be the Jacobian of uv function with respect to xy and j2 be the Jacobian of xy function with respect to uv, then the product of j1 and j2, this is equal to 1. Thank you.